Today we're going to work on the laws of exponents and negative exponents and zero exponents. So we're going to go ahead and start with the laws of exponents. Last class, we worked on expanding out and then simplifying, but there's certain rules that help us with this. Now, this being said, a lot of the time, many students learn the laws of exponents and then they use them wrong. So when in doubt, expand it out and solve these problems the way we did last class. Because the thing about laws of exponents is when you're doing it wrong, the way that you're doing wrong logically makes sense as well. So you think you're doing it right. So either memorize these really well and make sure that you have it down. We're going to get lots of practice today, or use the technique we learned last class, which was go to expand them each out in expanded form, play battle, and then bring them back together. So here are the laws. Our first law is for multiplying exponents together. So here we have x squared times x to the ninth. Now, what we did last class is we multiplied these out. We did put them in expanded form. So we have x times x for x squared. And then we have 9 more, x times 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 x. We then counted all of the ones that we had together, and we found out there were 11. So x squared times x to the ninth is x to the 11th power. Now, what this means is we can make a rule of this. Look at that 2 and that 9. Look at the final answer. What do you think we're actually doing to that 2 and the 9 to get an 11? Of course, you know. Now, the base stays the same. You can only do this when they have the same variable. So the base stays to be a plain x, and then we add the powers. So x to the 2 plus 9 is x to the 11th. So when multiplying, the base stays the same. Add the powers together. Remember, they have to be the same variable. Now, we're going to look at dividing, which, as we know, looks like a fraction. And this is where we played battle. So if we have x to the 8th divided by x squared, we would normally expand that out with 8 x's up top. X times 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 x. And we would have that over our denominator, which is x times x. We then crossed off the same exact number of x's on the top and the bottom. We then counted how many we have left, and we have x to the 6th power for our answer. Now look at the problem. What do we do to an 8 and a 2 to get a 6? Well, of course you know, we subtract. So the base stays the same, which means it's a plain x, and now we only have one in the numerator, and then we subtract the powers, numerator minus denominator. Okay? Now, the next one that we're going to do is power to a power. Now, power to the power is an exponent that's taken to another exponent. We had practiced this last class. So we have x to the 3rd power squared, which we know is x to the 3rd times x to the 3rd. And then we can expand that out more to be x times x times x times x times x times x. We bring those back together, and we see that it is x to the 6th. There's 6 altogether. So once again, look at the problem. X cubed squared, x to the 3rd power squared. What do we do to a 3 and a 2 to get a 6? You're right, we multiply. So the base stays the same, and we multiply the powers. So we have x to the 3 times 2, which is x to the 6. So these are the 3 laws of exponents that we use, and it allows us to do these mentally as opposed to writing them all out longhand. However, like I said, unless you have them memorized and have practiced consistently, it's easy to make a mistake. So you have to make sure you have that page of notes out and you're looking for exactly what you're going to do. Okay, now we're going to go ahead and work on zero exponents. Now, what if we have a letter and or a number to the 0th power? So we have 2 to the 0th power. It's 1. What if we have x to the 0th power? It's 1. What if we have 458 to the 0th power? It's 1. So anything to the 0th power is 1. Now here we have it in a problem. x to the fifth divided by x to the fifth. We know when we have the same thing on the top and the bottom, it is always equal to 1, like 5 over 5 is equal to 1. But if we use our recent laws of exponents, that would be x to the 5 minus 5, because remember, base stays the same. We subtract numerator minus the denominator. 5 minus 5 is 0. So we get x to the 0th power, which is 1. So anything to the 0th power is 1. Not 0, that's the most common mistake. Anything to the 0th power is 1. Now we're going to look at negative exponents. Now, negative exponents are a little bit weird. It's once again not multiplication, but what it tells you is it's in the wrong location of like a fraction. So we have 5 to the negative second. What that really means is 1 over 5 squared. So it currently is in the numerator, and there's no denominator. So we move it into the denominator, and we make that negative exponent positive. Now, all of your answers have to be a non-negative exponent. So you always have to finish up all your problems by moving it to the denominator if it's negative, or if it's in the denominator and it's negative, you're going to move it to the numerator and make it positive. So I always think of that negative as kind of like a screaming child at the supermarket throwing a temper tantrum. Ah! And what does a good parent do? A good parent takes the temper tantrum child and leaves the store. They go to the second location. Once that child is out of the store, maybe they're at the park on a swing, then they become positive. And that negative, that crying, that temper tantrum behavior goes away. So we then work out our 5 squared. 5 times 5 is 25. And so the answer for 5 to the negative second power is 1 over 25. So here are the rules. 1, you can't have negative exponents. You move them to the other side of the fraction. So if it's negative in the numerator, you move it to the denominator. Once again, if you leave everything out of the numerator, you then put a placeholder of 1. If it's a negative in the denominator, you're going to move it to the numerator, and you have to remember to make it positive. So once you move the location, it's not having a temper tantrum anymore. It's happy where it is, and so it becomes that positive exponent. And then simplify using the laws of exponents. So here we have x to the negative 4th y squared. So I look at the x, and the x is throwing a major temper tantrum. It's going, wah, wah. So we're going to take it out of the grocery store, and we're going to put it in the denominator. We're going to take it to the park. So that's going to go ahead and move to the denominator. And then we have a y to the negative 3rd in the denominator, and that y is freaking out. Wah, wah. So it doesn't want to be in the denominator, so we're going to move it to the numerator and make it positive. So once that y to the negative 3rd goes up front, it's now y to the positive 3rd, and the y squared was already fine. If the kid is fine and not throwing a temper tantrum, you're just going to continue doing your thing. And then that x to the negative 4th is going to go to the denominator and is going to become positive. Now we're going to simplify using that laws of exponents. So we have our y, and it's a multiplication. So our base stays the same, and we add the powers. So that's going to be y to the 5th all over x to the 4th. And that, ladies and gentlemen, is how we use negative exponents. We're going to get a lot of practice today in our Desmos activity.